In this video, we'll be looking at how to simplify a radical. So we'll be focusing on multiplication, but I do want you to know what it looks like if a radical is not simplified. So you know a radical is not simplified if one of these two things are happening. This should be a D. All right, you know a radical is not simplified if, first of all, there is a factor with a perfect square root, or a perfect root, because we could have radicals with other things other than square. So I'll just use the word root. So if there's a factor with a perfect root, it's not simplified. You also know a radical is not simplified if there is a radical in the denominator. And we're not going to focus on that in this video, but I do want you to know that that is also another way in which you know a radical might not be simplified. So if there's a radical in the denominator. All right, we're going to actually be focused on that one, and so let's go ahead and start. Before we can start to simplify radicals, it's pretty important that we know one thing, and that's the multiplication property of radicals. So let's say I have a radical. Let's say I'll just put n here as the index, and a here is my radicand. And I have another radical with the same index, so let's say n here again, but then a different index perhaps, a different radicand perhaps. If I have the same index, so here I have the same index as I have here, I'm free to multiply these two numbers, no problem, and put them under the same radical sign here. So we have same index, the index does not change, and it is equal to a times b radical a times b. Okay, so that is a rule that we need to know in order to be able to simplify radicals. So just to make sure you get it, let's say we have cube root of 9 times cube root of 3, and we're multiplying them. That is just the cube root of 27. So actually, we could simplify that further. You should know about cube roots. The number that multiplies by itself 3 times to get 27 is 3. So we were able to simplify that. All right, so now let's go ahead and look at how to simplify other roots that have a factor with a perfect root. All right, so I definitely wanted to throw an example like this in here. So remember what I said makes a radical unsimplified. If it has a factor with a perfect root, then it's not simplified. So we're looking at radical 5 here, and the factors of 5 are 5 and 1 and no more. So then you have to ask yourself, does any of the factors, or in this case either of the factors, have a perfect root? The answer is no. Neither of these factors have a perfect root, which means that in this case, radical 5 is actually the simplest it can get. So the answer here is radical 5. We have simplified the radical. It's already simplified. But let's look at a harder one that we actually have to do something with. So example here, simplify radical 50. All right. So we're asking ourselves the same question. Does this have a factor with a perfect square root? All right, it actually does. And the factor with the perfect square root, you may know, is 25. All right, so if it does have a factor with a perfect square root, you want to break it apart into that perfect square root and whatever else it takes to make up that number. So we're going backwards from what we just learned about multiplication. This is, in fact, radical 25 times radical 2. Remember that it's the same if I separate it out as if I have it together. I'm separating it out because of what you're going to see happen next. Radical 25 is, in fact, when we square root it, we get 5. Oops. And radical 2 is just radical 2. We cannot simplify that any further because that does not have a factor with a perfect square root. So now that we have simplified it, now that we have only a number with no perfect square root or no factor with a perfect square root, we know we're finished and we've simplified it. Let's look at another one that's similar so we can get more used to this. Okay, so here's another example, very similar to the last one. I'm going to do it in the same way, but I'm also going to point you in the direction of how to do it in another way if you're a little bit stuck. All right, so here we have root 600, and the question you want to ask yourself is there a factor with a perfect square root? Right away, I can see that 100 is a factor of 600, and 100 has a perfect square root. So I would separate this into 100, and what multiplies by 100 to get 600? That should be 6. All right, so then we can take the square root of 100, and we get 10, and we have root 6 here. Now, in order to figure out if it's fully factored, you still have to go ahead and ask yourself the question, is there a number or a factor of 6 with a perfect square root? And there is none, which means that this is fully simplified. Now, let's say you were doing this and you could not think of it. You just thought, oh, I know 25 is a factor of 600 with a perfect square root. Well, let's try it that way. So if you thought of 25, then you would have 25 here, radical 25, times radical 24. All right, so in this case, you would say, well, we have 5 times radical 24. But you would then have to ask yourself, is there a factor of 24 with a perfect square root? And there actually is a factor of 24 with a perfect square root. So we would have 5 times, and we could separate this into 4 and 6. Now, with that done, we know that the square root of 4, so I chose 4 because 4 is a factor of 24 with a perfect square root. So now we can find the square root of 4, which is 2, and 6 does not have a factor with a perfect square root, so we have to leave that under the radical. We can now simplify by multiplying this, and we have 10 root 6. So if you were absolutely totally stuck, you would be able to break this apart into smaller pieces. But the key here to make sure that you do it in the simplest way you can possibly do it is to try and find that largest number, or as large a number as you can find with a perfect square root. All right, let's introduce variables. Actually, I'll do that in the next video. So stay tuned on how to simplify radicals with variables.